Okay, so last time we finished up by testing out this engine with those new hydraulic lifters, and it does kind of seem like getting away from the solid lifters on this hydraulic camshaft seemed to be a good thing to do. It looks like we're back up to where we were before, about that 270 horsepower mark. Now that I'm done with that, I'm ready to move on to the 1.7 rockers. So what I want to get done in this video is, first what I want to do is, we're going to take the valve cover off obviously, but I'm going to go back to the light checking springs. And what I want to do, you can see down there, I got my degree wheel put back on. And what I want to do is I want to try to plot, well, a couple of things. I want to plot, mostly what I'm interested in is plotting the valve lift versus crank angle for both the 1.6 and the 1.7 rockers. And then we can put that into a spreadsheet and kind of make a curve of the data and kind of see how they differ. I think that might be interesting to look at. And then the third thing we can do there is we can also I can also take the rocker arms out and put the dial indicator on the top of the push rod so that we can look at a curve. We could have 3 curves there for each valve. Right now my plan is to kind of do that in maybe 10-degree increments. At some point we'll have a look at the new rocker arms that I got. And again, I'm not going to really go into the brand names and stuff like that. All I can say is that they are basically the least expensive pedestal mount 1.7 rockers that I could find. So let me get the valve cover off, get the light checking springs in, and we can get going. Okay, so I just wanted to show real quick the setup I'm going to use to do the, try to get the profile at the tap at first. So I'm just going to go off of there like that. Down here I got the degree wheel set up, and this time I got on the correct TDC mark. Just going to indicate off of the water pump there. We're not trying to do anything real precise. It's just try to get an idea about how these profiles change. So I got the lift versus crank angle profile done for at the push rod basically. And I just wanted to show you how I'm going to do this at the valve. We'll do it this way with these rockers, and we'll switch over to the 1.7s and do it again. I got all for the intake and the exhaust, I've got the profiles recorded, at 10-degree increments there. So I guess the next thing to do is to get the new rocker arms out, but what we can do is just do a quick unboxing of that and have a look at them and kind of get a better idea. So here's the new rocker arms I've got. They're supposed to be 1.7. They are the least expensive rocker arms that I could find in a 1.7. I have not looked inside of this yet. I have no idea what's going to be in there. What I can kind of say though, starting off, is that let's see if you can hear this. I don't know if that's coming through, but do you kind of hear that? There's something loose in there. There's probably several things loose in there. So I guess without further ado, let's just kind of find out what's loose in there. The packaging is a little bit loose, and that sounds like the noises that I heard in there were this plastic or whatever this is kind of crumbling up a little bit. The other thing I heard rolling around in there is it was one of these. I think it goes something like that. I don't know. I'll give them all a good looking over. We'll see how it goes. We'll see how the install goes. But what we got to do next is get a pair of these out, get them over on the engine, and then do those same tests we did before. Okay, so I finished doing up the lift profile on the exhaust and the intake. It did kind of what you'd expect, but we'll look at that. We'll look at those numbers in a minute. But what we can do right now is I also remeasured the duration at 6 thousandths and 50 thousandths here at the valve, and we can look at that real quick. These are the numbers we're going to be looking at now. So these numbers here are the durations at 6 thousandths and 50 thousandths that I measured. This probably would have been last year sometime. Those are the numbers I measured when I installed that the HO cam, and these are the numbers that I got today. Now, what I'm going to say is, like, These are the ones at 6 thousandths and these are at 50 thousandths. These ones that I'm not sure how much I'd take away from those because the the crankshaft moved quite a bit per thousandths of valve lift. So it was kind of hard to nail down exactly where 6 thousandths valve lift actually was, at what angle that was at. So I take these. I mean, it definitely seems to have picked up something from here to here. There's something to be taken away from that, but the ones down here at 50, these are the ones I'm kind of more interested in. And it looks like I picked up between 4 and 5 degrees of duration on the intake and the exhaust. It seems like that ought to do something. But what we can do next is we'll go in the house and have a look at the data that I collected, and we'll graph that out and kind of have a look at the lift profile. So here's all the valve lifts versus crank angles that I recorded. So this side here is for the intake. This is what it was at the tappet. This is what it was at the valve with the 1.6 rockers, and this is what it was at the valve with the 1.7 rockers. And then what I did over here was I basically just divided the valve lift by the tappet lift at each one of these points and calculated the rocker arm ratio, because the rocker arm ratio actually kind of changes a little bit depending on where it is in its travel. And you can kind of see it around here. Around maximum lift, we were showing like a 1.61, which is about what those rockers are supposed to be. And then with the 1.7s, we were getting to be like a 1.68. Seems like that's about the highest number I saw there. And then there's a 1.7 there. So you know, basically that was the purpose of doing this, is to roughly see what the rocker arm ratios were in the application. So that's what we got there. And I'll just and I did the same thing over here. And this being the exhaust side, and we got similar results from that stuff. So it looks like in terms of how much valve lift we picked up, it looks like it might have been around 20 thousandths maximum, roughly. It seems reasonable for the rocker arm change that we did. And then what I did was I just took all these things here and I put them in a graph so that we can look at them individually like that. And there's the plot we got. That's the blue is in that's the tap. Well, you can see it here. But the blue is the tappet lift. This one here is the 1.6 rocker, and the green is the 1.7. And it looks like I must have misread the dial indicator at that point. But you can see the curves there. And they actually came out pretty smooth considering the way I was doing it. These curves look pretty smooth and pretty reasonable. So anyway, like I said here, this is the intake side. And judging from this, I'd like to be able to see more resolution down here. Maybe I should have taken this at a smaller angular step size down here, because it would have been nicer to see how it was going to change down here too, in terms of how it could potentially affect the duration. But we did already see that on the whiteboard outside. So I mean, looking at this, I would expect that to do something. I can't be sure until we test it to see what it's actually going to do, but it seems to me like that should do something. Should be an improvement, I would think. Now, the other thing I wanted to say about this quickly was that this is just with the checker springs installed. The thing that's going to be different that might make the 1.7s not as good as they might seem is that the 1.7s are going to be pushing on the push rod harder than the 1.6s were. You know, and everything in an engine is basically a spring, so you know you're going to get more deflection in the push rod. The other place having it pushing on the push rod harder is that it could make the valve lifter bleed down faster and make this, you know, not be as much gain as what it might appear on the graph. So that's just something I wanted to mention. And we look down here, we got a very similar profile difference. Something I forgot to mention was this here. I think this is top dead center, 0 is top dead center, and 180 down here someplace would be like bottom dead center. So, and on this one, that's bottom dead center here, and up here would be top dead center. So you can kind of see the exhaust valves opening a good number of degrees before bottom dead center. And anyway, there's the graphs, there's the plots that I got. I guess you can study that and make your decisions, make your own decisions about it. But just wanted to show you that, and I think, yeah, I think the next thing to do is just to go out there and finish installing the rest of the rocker arms, and I'll show you what the way I'm going to do that and what I'm going to check. But yeah, let's finish this up here and get back out into the garage and let's finish installing those rocker arms. So I got the service springs reinstalled there, getting ready to install the rocker arms. But what I kind of wanted to do real quickly was just kind of talk about how I'm going to do that and what comes with the kit, more or less. So you got your push rod, obviously. And then one of the parts that you reuse that was on the engine originally is this piece here. And that piece goes on underneath, goes on there like that. And then you have this piece that goes on, and it goes on like that. And then the rocker arm fits onto here like this. And then this kit came with a an Allen head 5/16 coarse thread. And remember that that's coarse thread, because I'm going to be talking about some significance about that later on. And I'm just fitting this on here so you can see basically how the assembly goes. And then the other one goes on the same way. It'll line up there like that. Of course, I realize I didn't put that push rod in place, but I'm just trying to demonstrate something here. So it's a real simple install, really. One thing I want to show is that obviously these pedestal mounts here, they're not really adjustable. I shopped for these in 2 or 3 different places, and in 2 places I saw that people, when they bought these, frequently buy this kit with that. Now, what that kit comes with is a variety of shims that look like this, that look like that. And what these do is they fit down underneath here where they go in between here and the bottom of that pedestal mount. And what it will do is it'll allow you to shim the rocker arm up. And the reason some people might need to have the shim kit there is if the cylinder head or the block has had material removed off of it. Because if it did, then the head would move down closer to the camshaft. And basically what it would cause is you to have more preload on your lifter. Generally, people just do that in terms of, you know, bring it to zero lash and then give it such and such, like half a turn to a turn or whatever it is that's called for of preload on the lifter. But because this isn't adjustable, not really adjustable, if you've had machine work done on this, it'll bring the head down and it'll give you more preload on the lifter than you would have had otherwise, more than it was originally intended for. So say you had, let's just say you had 20 thousandths or so taken off of your cylinder head, or 10 thousandths or whatever it happened to be. That kit, say you had 10 thousandths taken off your cylinder head, well, you'd want to put like a 10 thousandths shim underneath this rocker arm, and you should be back up to the proper preload that you had before. And you'd want to do that on all of them. You'd say, you know, if you had 10 thousandths taken off the head, you'd want to do that to all of the rocker arms, not just one, obviously. So I just want to talk about that real quick. Okay, so what I want to do next is just demonstrate how I'm going to determine whether or not these things need shims or whether they're pretty good the way they are. Is I'll adjust them sort of the way I would a rocker arm that's on like a 3/8 inch stud mount. I'm going to kind of adjust it, like check it like that. So what I'm going to do is I'm going to just turn this down until I feel a little drag on the push rod. which looks like I'm pretty close to that already. Okay, so right about there. Right about there, I'm finding about 0 lash there. So now, what we can do, you see how many turns of this wrench I get before I notice that it's tightened down against the stud mount, or against the pedestal mount there. So we're starting about here. Okay, so it took half a turn. It took half a turn on this from 0 lash to where it was snug on there. Half a turn of the wrench from 0 lash to where it was tightened down on there. And that's about right. So let me check it again on the exhaust and see if we're close on that one too. Alright, so right there we got about 0 lash. And we'll see how much more turn I need there to get it tight. And in that case it was almost a half a turn. So it was a little bit less than half a turn. So what I'm seeing here is that we're looking at about half a turn of preload on these fasteners. We're getting about half a turn of preload on the lifter with these fasteners. Now you might have noticed earlier that I mentioned that they were coarse thread fasteners. Now, because of that, a half a turn of preload on this fastener is probably going to be more, I don't know what it would convert over to, but it would be more than half a turn on a fine thread fastener like you'd have on a fine thread 3/8 stud mount rocker. So that means that it would equate to a bit more than half of a turn of that. So if the way I'm looking at this, at least with these two right now, it looks like I'm somewhere between half a turn and a turn of preload that I've got on the lifters, and I think that that's acceptable. So if they all turn out like that, I won't have to shim these at all. It makes sense that I wouldn't need a shim because the heads have not been milled, the head gasket is the stock thickness, and the block has not been decked. So that makes sense to me that would work out that way. And so that is the procedure I'm going to use to install them. And then the last thing to know about that is each one of these, each cylinder, I will do them at top dead center compression like I did on this one. So these ones were adjusted at TDC compression, and I'll do that the same way with the other 7 sets of cylinder heads. And then the other thing I'll do, this is just here mocked up to show you, how I'm doing it. But I'm going to take these off real quick, give them a quick bath in oil. I'll just dunk them in oil real quick, reinstall them, and I'll move on to the other 7. So, all right, let me go do that, and we can move on from there. Something else I just wanted to mention real quick is, and this should probably go without saying. I know most people would probably notice this, but you see this side of that axle there has that flat spot on the top of it. Well, if you turn that around, it doesn't have that on the other side. And I think what would happen if you put this in, so this side, the flat needs to be up where the bolt can meet to it, where the bolt bolts down to that. And I think if you had that upside down, that wouldn't be good. So anyway, just something to keep an eye on. Make sure you install that the right side up. And I guess one other little simple thing I would say that would make this a little bit easier is just don't take both of the old rocker arms off at the same time. Just take one off at a time. And then that'll hold that U-channel shaped piece underneath here in place while you're installing the new rocker arms. So it just makes it a little bit easier. They all do have that quarter of a turn to half a turn of preload. So I'm going to run them like that, and hopefully that all works out. So anyway, it says right on the box, torque these to 15 to 17 foot-pounds. Alright, so there they are all torqued in place there. And what I thought I could do is just crank it over for a second or two, and you can see how they move. And then the other thing I did while I was here like this is I put the valve cover on without the gasket and just held it in there in place. I put 2 bolts in but didn't tighten them down just to make sure it was aligned on there, and cranked it over, made sure that I didn't feel the rocker arms hitting the valve cover anywhere, and I didn't, so that's hopefully a good thing. So let me get that back together and we can move on. Okay, so we did a couple of dyno pulls there. Both of them came out pretty smoothly. This is the first one I did, and I decided to do another one because I started it the pull with the engine temperature hotter than I thought it was. So by the time it was done, you know, we were close to 200 degrees. To me, that's not a fair comparison there, because I think we were quite a bit cooler on the previous test where we put the new roller lifters in. So I decided that one wasn't a bad pull, but it got too warm, so I did another one. That's why anyway, that's why there was 2 of them. So let's have a look at the second one. So here's all the data from that pull, and I'll just scroll through it. I'll just scroll through that so you can see it before I do anything with it. And the second one, the torque came up quite a bit, and we were running about 40 degrees cooler on that second run. So that apparently influenced the torque numbers a little bit. Because I didn't change anything from one test to the other than the temperature of this. The other thing I want to say now is that I think over the winter, I'm gonna make a project out of seeing if doing some calibration work on these RPM numbers, because I think I need to do some data smoothing on that. I mean, I don't think they're not terrible numbers, but some of them make me the way they kind of go up and down. That's a there's something not quite right about that. Now I can kind of I have a looking at it, I see some that I think are okay, but when some of them move up and down so quickly, like from here to here, you can kind of that didn't happen. So anyway, what I'm gonna do is I'm gonna just go through here, look at the ones that look reasonable to me, and then we'll clean that up and we'll look at that next. Um, so I guess, but the main thing with this one here was that the the coolant outlet temperature was like 40 degrees less on here, which is this might have been a little bit cooler than the previous test with the that I did in the previous video, but not much different, I don't think. So anyway, that's what we got there. Let's go to the next spreadsheet and look at the data. Okay, here's the cleaned up numbers that I got. These torque numbers are very similar to what I've seen before. Sometimes they're a little bit, I think it depends, it may depend on a number of things, but these two high 280s, low 290s torque is basically what I'm used to seeing this engine do. And it looks like, I see that one's kind of like the highest number there, but for I'm choosing this one as the peak torque number, and that correlates better with some of the previous numbers that I've got. So I'm going to go with that one, even though it's not the peak number, which kind of came in there. And so that's what I'm going to use in the corrections. And then the other thing is I've talked about this before, but this is the horsepower that the data acquisition calculates, and it tends to be out of phase a little bit and tends to miss some of these numbers sometimes. So what I have over here is it's basically this column times this column divided by 5252, and these are the horsepower numbers that I'm using over here. So it looks like we made about 200 and I'm okay with rounding that to 277 horsepower. And so that's well, anyway, we'll talk about how that compared to before. And here's just a graph of some of the numbers. So something kind of interesting going on there. I'm not exactly sure what that is. I've seen something like that in the previous test. I don't know if that's like the headers resonating or something, something tuning in there for a brief period of time. I'm not sure, but or it may be nothing. It may just be error in my data. The other thing I'll say about the tune is that I didn't change anything in the carburetor and I didn't change anything in the distributor. So the fuel and the timing, everything was the same, exactly the same from the previous video and this video. I didn't mess with that at all. So here's all the numbers that I've gotten to date, and where we started out, and this is what these are the numbers that I got for today. And kind of looks like we went down 3 horsepower, and we went, mostly what I'm taking away from this is that it appears to me that the 1.7 rockers didn't have as much of an effect on the performance as I would have thought. And this torque being higher here on this one, I'm not gonna attribute that to the rocker arms because it's not the highest. I've gotten that kind of torque number before, so I think that was more maybe a result of what was going on that day in terms of the engine temperature and things like that. What I'm seeing there is that to me it just doesn't look like those 1.7 rockers did very much. Looking at that crank angle versus valve lift profile, I would have thought that would have done something, and especially when I saw that we gained like 4 to 5 degrees of duration at the valve, I thought that would have done something. But I think the thing to keep in mind with those numbers there and that data that I collected is that was done with the checker springs installed, and maybe what it's actually doing with the service springs installed might be a little bit different. Because the 1.7 rockers are going to be pushing on the push rod and the lifter with more force, and that, who knows, maybe that could be causing the lifters to bleed down a little bit more quickly, but I don't know, that's just a guess. I really don't know what whether that was the case. You know, and then something else I just thought about recently was that there's one thing, there's something in my dyno system that I'm neither controlling nor compensating for. And what that is the fuel temperature. Now, it's been a while since I can't remember exactly, but the night before I ran this test here, I think it got pretty cold outside, like maybe into the low 30s, perhaps. And the night before this one, it wasn't nearly that cold. So, the outdoor temperatures were warmer on this day than they were on this day. And the thing to know is that I keep the fuel tank. The fuel tank is outside. So I would say I can't prove it because I didn't measure it, but I would say that from this test here to this test here, I wouldn't be surprised if the fuel temperature was 10 to 20 degrees colder on this one. And I've seen that, it seems like I've seen a test done before where they, basically did those, they just chilled the gasoline going into the engine and it showed a performance difference. And to me, it would do that. It would do that. So, I can't prove that because I didn't measure it, but I have that's a suspicion that I've got that maybe that's where some of this horsepower went. It's possible, and it's possible that maybe that the horsepower, if the fuel temperature increase caused me to lose horsepower, well, maybe it's possible that the fuel temperature increase caused me to lose more power than the new rocker arms gave me, because I really would have thought that those would have performed better than they did. So, but these are just the numbers that I've got. I can't say for certain why it happened that way, but those are some ideas that I got. The fuel temperature, and that possibly the 1.7 rocker arm pushing on the push rod and the lifter harder, maybe it didn't have the gains there that it seems like it would have. So anyway, those are the numbers I got. I guess the next thing to do is just to go out and wrap this video up with a quick conclusion. Now, something about roller rockers, in my opinion, and it's been my opinion for several years now, is that the choice to upgrade to a roller rocker, for me, usually has to do more with the strength and reliability of the roller rocker. If you've gone up in valve spring or gone up in valve lift and camshaft and RPM and everything, if you've increased your engine performance in those ways, it's going to put more stress on your rocker arm, more than likely. And I have seen them break in those situations. But so to me, the roller rocker is more of a reliability thing and a strength thing, and maybe a little less of a performance thing. Having said all that, it's kind of still disappointing results this week. I really thought those 1.7s were gonna be kind of would have done a little bit different than that. So at any rate, it's just kind of a little disappointing, but that's the way it goes sometimes. That is all I've got for this week, and I will see you next time.